Hey, how's it going, everyone? We're getting things set up here. One moment. Getting things a little set up here. Clicking the buttons. Where'd that at? Oh, here it is. Okay. Okay, what we have here is we want to do batching. So we've got our click predictor. Let's take a look here real quick. We've got our click predictor, and it looks like this. It is performing better, in my opinion, with just the few samples that it's currently training on. You can see every training sample is being visualized right now. What I want to do is start batching it because we need to get more data happening, more data. It's not, and then we need to run through more than one epoch. Hey, just a random. Am I the first? Yeah, you're here. You're the first one. Good to see ya. We're going to continue today on our click tracker. I want to do batching. I want to see if we can get some really good results. Because right now you see that little yellow dot on the screen, that little yellow dot that you see on the screen. It's kind of flowing all over the place. It's not really going where I think it should go. Right? It needs to be aligned with those green dots, and the green dots are happening all over the place, but the yellow dot is just kind of wandering all on its own. So I think we're at the point where we've got a good model and we just need to train it properly. We've got to pre-collect the data, pre-aggregate the data, and then batch process it using a hardware accelerator, which right now it's currently all CPU based. It's all CPU based because you're just looking at every training sample and its adjustments over time. And we probably adjust the learning weight and some other things from there. So that's what we want to do today. And we might have. I do have to jump in a little bit. Hey, Quantified Quantum. Hey there. How's it going? Good to see ya. We're look out. Look at what you did. See the click tracker? See that click tracker there? That was you. That was you. You're the one who got this started. And so we've actually got things are actually looking pretty good. So now it's using a convolutional neural network. It's improved over time. And I want to now start getting more data loaded into the model. How's it going there? Vibe Hawk Akutatha? I didn't say your name there. It's good to see you. We're gonna get this to actually click predict a little bit better. I think we can do it. I'm pretty sure we can do it. How's it going there, Xerxes? How do you say your name? I'm gonna say Zerzez. All right. Just Vibehov. Okay, it's just Vibehov. Okay. Sounds good to me. Thank you for being in here. Good to see you guys. All right, so the plan is we're going to start doing some batching. So I might use the data loader. I probably should use the data loader. I wanted to do it by hand because I already know how to loop through things and collect data ahead of time. And I need to pre-generate all the embeddings so that way it works out really nicely when we do the batching. Or I suppose we could do the batching. No, let's pre-process the batching first. Let's get all the things in the right batch size, and then we'll get the labels going. Hey, look, we're just. I like how the yellow dot just disappeared out of random, like it just vanished. It's wandering off screen. There it is. Here's the yellow dot right here. See the yellow dot? It might be hard to see. I need to maybe make that yellow dot maybe something a little bit brighter to see. That might be a good idea. So let's get going. Let me see. Copilot disable. We want to make sure we're not using any AI here. Okay. So where is our, let's see, CRRC? Where's our circle at? Let's get that to a little bit different color here. Just a smidgen of a different color. So that is yellowish. Let's make it magenta. So red, full red. And then no green, and then full blue, right? That's magenta. I think that's magenta. Let's double check that. Let's double check it. Yeah, there we go. There's magenta. Now you can see it a lot better. That's a lot better. It literally just T-boned. Oh, you did? Holly, you just did? That's crazy. Hey, Carmu, how's it going? Welcome on in. Good to see ya. We're gonna adjust our AI model. I like your energy in here, and is night now in India. Is it? It's nighttime? Nice. Very nice. Yeah, it's morning here, over here. It's 8:40. It's 8:50. It's 8:50 a.m. here in USA. So I'm really excited. I want to get the batches going. So we need to do some batches. I think that's going to help improve us actually achieving higher. So we're looking at the loss and the cost here on the screen. It's kind of hard to see because it's kind of flickering. Is it improving? It is slightly improving. Slightly. Not a lot. It's just jumping around a lot. So let's see if we can make that better. Let's see if we can make it better. All right, so where's our model at? Our model's up here, and I know we are printing out debug. It's got to be in the model somewhere. Wait, hold on. La 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 la. Where's that debug at? So there is some debug stuff happening here. Where's that at? Weird. Debug value. Where is that? Oh, here. See. Oh, got it. Wait, why is that still... Here's the question. Why are we seeing the output like this? It looks like it's debugging to me. It looks debugging. You know what? Let's scale it. Multiple windows, one model. That sounds great. What do you mean multiple windows? I'm actually kind of curious. When you say multiple windows, so currently what we've got is when you see the clicks on the screen, the current click dots, that's actually what the AI sees, essentially. The AI is actually seeing those dots at those locations, essentially. And so what we could do is we can make the dots more prevalent based on their frequency or in their occurrence, the order of occurrence. So what we could do is we can represent a higher order of occurrence by making the pixel bigger, something like that. That's something that we can do. 885? What are you doing there, Elliot? What are you doing? Multiple game windows opened. Training data gets combined and sent to the AI. Oh, gotcha. Okay. So good news. We are essentially going to do that through batching. And so so right now you're seeing each training sample one at a time. I'm going to do some batching, and I'm going to do some big batching, and it should accelerate the model's training like light speed. It'll be light speed. It'll be like 1,000 times faster. And so that's what we're going to do now. That's the plan for today. Although I do have to go in about 30 minutes, and then I might be back. I'm planning to be back later today to continue to get the batch going. So where is the data? Where is this happening at? Why is this where print? Let me see the print at. Print output. Maybe we don't need that. I don't want that. Okay, I don't need this anymore. Don't need that anymore. This is the old one. Let's just delete this. We don't need that. Let's get rid of that. Which machine are you using for training? Here, I'll show you. Let's see here. No. It's a pretty good machine. It's got hardware acceleration. Hey y'all. Good to see you, Savon. Saw your message on Discord. We're looking into it. I already pinged HR. We're looking into it. We'll see how it goes. I'll let you know the answer. We'll let you know the answer when I get it. So it's a pretty good machine. GPU accelerator. It's got plenty of memory. We're good. Let's see here. Okay, so so here's our encoder, game window, coordinates. Okay, so this is each. Wait, hold on, game. All right, so yeah, that's the game. This will give us one sample as the encoder. What we need to do is pre-generate all the samples with the coordinates into a full data set. That's what we got to go. Cool, appreciate it much. Yeah, happy to help. I'm actually curious myself. I'm going to see what it is. Could be. I've got some ideas. We'll see. I'll let you know the real answer here. Okay. So here is this. This will encode one sample. This is a forward, and I'm not sure. I think here's the train. Okay, so here's the output on the train. How do we want to do this? I suppose since it's you know what we could do is, well, is it good enough right now? So I need to do model.toDevice. So we've got our device here. Where's our device at? I know we've got it. All right, so here's the device. It's got its accelerator, and we just never put the model to device. So we should do oh wait, we already did this? Hold on. Hold the phone. We already did this? When did this happen? Hold on 1 second. Wait. When did this happen? Did we do this? I need to see here. All right. Device. Self-set device. Click this button. Click here. And then click reference blame. That's what I'm looking for. When did that happen? Where'd that at? Right here. To device. So it only happened just today. It only happened today. And you know who helped us out with that? Was Neva. Neva helped us out with that. I was wondering. I'm like, hey, hold on a second. When did that happen? I'm pretty sure I didn't do that. All right, so now that it's already on the device, let me see here. Let's see if there's any other two devices. No, only that. So if that's the case, we should probably also put the, although I believe it's automatic, once this happens, the output encoder, where is that's the CNN encoder. Here's the first encoder, which takes the data and puts it into, let me go back to this. All right, so this normalizes the data. Although I don't think we're using this anymore either. We're not using this anymore either. We're only using this. Okay, so let me just mark this as old so we don't, I might reference this later. Okay. Then that means if that's the case, then right here, all we have to do is, oh, it's already on the device. Oh, we're good to go. I didn't even notice that. All right, so now all we have to do is the batching. We're making progress. We don't have to do anything. Hey, Steven. Hey, Neva. I just saw we're going over some of your changes here. Thank you. Hey, Kevin McAllister. Good to see you. Welcome on in. We're going to make some adjustments here on a model. Neva made some great adjustments. We were just going through it here. Where's that at here? Right around here. You can see the different things that Neva did here. And we've got the data now running on a hardware accelerator, which is great. I'm going to do batching. We could use the Pytorch data loader. We could. Before we do that, let's at least get the data into the shape that I want it to be in to be prepared for a batching scenario. Although, if we do that, we do need to update this line right here. So this line right here. Let's see. Is it going to let me? Okay, here we go. This line right here. So this will be the number of batches, essentially. We need to update that so that way the encoder won't automatically create a batch of one. So that's what we have to do. Oh yeah, I realized the bug I thought I found wasn't a big deal. I just got confused since TensorFlow and Pytorch do it the opposite way. Yeah, they're different. They make some differences there. And I thought, I didn't know either. We're learning together here. Neva, we're learning together. Whoa, Neva, cool work. Yeah, Neva's done really great work here. I think this is fantastic. So this is the batch. We do need to update this line right here. So that way, once we get it into the right shape. So what we could do is the encoder, we can assume that the forward pass is always going to give us a batch of data. So we have to make some updates for that. And that's what we should always do. That's normal, standard, expected behavior. Like TensorFlow does X, Y, C, like the pixel position and the color, the channels and the color. Pytorch does it color X, Y. Oh, does it? I did my CNN work in TensorFlow before. After that, a bunch of Pytorch. So I got it mixed in your brain. All right. So then Neva, here's the question then. If that's the case, if you're telling me that's the case, then is this considered the batch here? That feels wrong. It feels like this would be the batch, right? In my mind, it feels like this would be the batch. Like we're looking at it right here on this line, right here. I feel like the first 0 counts as the batch, even though you said that. And the second 0, or the last 0, would be the color channel. I think. Tell me I'm wrong. I don't know. In forward, I'm flipping it in my permutations. Okay. What we'll have to do is we'll have to test it out. I'm pretty sure. 0's 1. Okay, so, or is it? Oh, see, we've got 1, 1. So here, we also have to update this. Okay, so to do update 1 WH 1, and the same here. So we have to do that. Why are we batching basically, and in what format? Sorry if this is a stupid question. It's a good question. We want to batch because right now, the training speed obviously is very slow, and the output is not converging to the right answer that I want. So as you can see, it's really fun. It's wandering all over the place. It's like it doesn't know where to go. It's fun to watch it wander. So we need to update it so that way it starts converging on the right answer, because right now it's wandering around, and it's fun to watch it wander. I like that the magenta dot, see it wander around. I want to see it converge faster. So we'll do a batch training, probably like a batch of 64 or 128 or even 256, like really big batches. So that will allow us to go poof and have the GPU go poof, give us all the data all at once, like poof, and then each batch will print on the screen the result, just like the last one. Or we could render all of them if we wanted to, so that way we don't lose any of the resolution, although I think every batch would be fine. Oh, by the way, I played with a bunch of the methods for the CNN and think it might be a dead end looking at transformers right now. Oh, really? Okay. So you think that the CNN might not be good enough. Because right now, you're right. It doesn't have any concept for order. It doesn't know which pixel is where. It's just seeing 3 pixels, and then it needs to assume where the next click is going to be. So right now it doesn't know. So in order to like represent the order, I was thinking that we could add more data, like make the pixels bigger, like add more pixels, put more ones essentially for the first one, and then do a line for the second one, and then just a dot for the third one, something like that. The issue is it's overlay local. What do you mean? Like the time you see the stuff from 800 pixels away, it's a nightmare. Oh, so it's just too much, not enough. It's like the density is too low, maybe? Are you letting it move freely from the clicks? I saw yesterday it only allowed it to move when you clicked. Oh, so it's actually pre-recorded. So these are our real clicks. These are real clicks. So you can see real clicks. All the green dots are the clicks. And now it's not random clicks. It's actually me. It's me recorded clicks. And then we saved it. Maybe make the size of the pixels and synthetic image the same size of the click feedback. So we could, right? So we could also change the pixel resolution before input. So that's something else that we could do. Because right now it's 100% resolution. It's a full picture. It's like big. It's like big picture. It's a very big picture. MPS, good to run MPS. Okay. Basically, the CNN only looks at local input to the size of the kernel, 77721 pixel distance. Accidentally deleted transactions table. Oh, you did? Oh no! The good news, what is DVC? You have a backup? I hope you have a backup. That sounds like a good idea. Oh, backup sounds great. Let's see here. Okay. 1 second. I'm clicking some buttons here. One moment. Where is there more? Can we do more? Let's click here. I guess we'll just click this button here. Okay. Yeah, data version control. Oh, nice. Okay, good. Okay, so a backup, essentially a backup. All right. So we do have 20 minutes left, and I got to get going, but we'll be back a little bit later. Today is the plan. Let's see if we can get some of the batching going, because I want to get this in the right shape. So we have to update this, and then the forward is going to be expecting it to be. So let's get rid of that. So that's the features. Features, encode, self.game. Features, we need to batch it. So we're going to assume the forward is already a batch. So when we do the forward, the features is a batch already. So where is this happening at? Self.train. So I would need to maintain it. We have to do this. So let's try this. So I think we just do this, and then we do this. And that should do the trick, maybe, hopefully. I think so. And so that should do it without us having to worry. And the output will be 0, something like that. So our decoder should also assume a batch, and the encoder should also assume a batch. Which means that we need to output multiple. We have to do that. So this might to do here. Okay, let's see. Is that going to work, or is that going to cause an issue? Oh, chords pose 1, chords, pose, and chords 0. So yeah, okay. So we need to do some work here. Okay. That should have fixed it. Right? Because the features input is on the forward. Oh, wait. Where do we do that at? Forward features output. Oh, okay. So that's just the train. So let's update that here for now. Although then that makes it not a tensor anymore. Oh, I keep forgetting about that. Okay. So where are our features defined at here? Let's see where when we put it into the forward is where we really need really need it to work the way we want it to. So where is that at? Forward train features. So yeah, it would be right here. So this is already not yet a tensor when we run it through the train here. Features. All right, perfect. Okay. Okay. List index out of range, chords 0.1. If you need a list of tensors to a tensor, you can use a stack. That's interesting. What is that? Okay, I'm going to look that up so I understand it. Pytorch stack. What is this? Function in Pytorch concatenates a sequence of tensors along a new dimension. Oh, that's pretty neat. All right, let's read this. So you can combine A and B, essentially, which then creates a batch. Nice. Okay, thank you, Neva. Thank you. This is great. Okay, so that's pretty fantastic. This keeps gradient 2, which is how you avoid the NumPy setup. Oh, nice. Okay, good to know. Excellent. We're learning new things. All right, so this is the whole point, right? This is the whole point of wanting to build with Pytorch, just so that way we can get into how Pytorch wants you to do it. Okay. Let's see here. Model sequence. Forward. Okay. Expecting. Wait, 1 second. Where'd the features at? Features are going to be. Wait. Who's that? Torzan? Hey, Torzan, thank you for subscribing. Welcome on in. So if you didn't know, all right, so this channel is, I'm Stephen Blum, CTO at PubNub. We've raised 134 million. We're at a Series E. We've got 1 billion connected devices and 68 patent claims that have already been granted. I've been in tech for 25 years, and I'm excited to tell you about all the things that worked for me. This essentially means that we're going to be focusing on mostly coding from scratch without the help of AI. And if you have any questions along the way, I'll be happy to answer them for you. Can we not create NumPy in dimensional matrix and convert it to a torch type? Yes, we absolutely can. You absolutely can. In fact, they kind of like it. Pytorch and NumPy, they kind of like working together. They so much like working together that NumPy is included in Pytorch. It's like automatically included. It is a great to and fro. So thank you for your subscription. Thank you. Let me see here. You shouldn't do it when working inside a model. Yes. When inside the model, you want to be pure Pytorch. So that way you create a cohesive, unbroken graph. They're BFFs. Yep. They're best friends forever. Let's see here. Where is this at? 1 second. I'm clicking some buttons. Button. Here we go. Over here. Make sure I get everything set up here. Okay. Now let's go back to our screen. And we need to figure out how to batch. So is this okay? Forward. Okay. So this when we run forward, it should already be in the shape of a batch. I need to make sure that we do that. Yeah, BFFs. I figured, Savant. I figured best friends forever. I figured you mentioned that. I figured. I translated it. Okay, so where's our forward at? Features. Yes, this should be it when we run the train. Although I would rather maybe this be like this, and then label like that. So it's assuming it's a batch, right? So that'll be a batch. Okay. Yeah, maybe. All right, maybe. We'll keep going. Okay, train. Let's get the features. All right, assuming features in the forward should be expecting this to be a batch. This should also be a batch. So let's update this. Let's update the encoder. So four chords. Well, I guess I should say features here. Features. Get and then we need to do another for loop essentially. Output 0. Okay, so yes, so four chords in features. And then we need output. Output equals an array. Output. I'll just say out here. Out equals that, and then we want to say output dot append out like that. Let's double check. Yes, looks good. Okay. Chords, features, position, looks good. Okay, so the only thing I need to double check here is, hey Kyle, how's it going? Happy Tuesday. Welcome on in. We only have 12 minutes left, and I gotta run for a meeting, and then we'll maybe be back later today. We might be back later today. That's the plan. That's the plan, you guys. Let me see. To do. Validate correct dims. Okay, so this should be the way I want, I think. 20 minutes, I know, right? Always 20 minutes. Torva, how's it going? Good to see you. Okay, short stream, got it. Yeah, it's a little short stream today, and might have a second. Well, maybe do a second because we didn't have a very long stream today at the beginning. Because we're getting back into it now. The year is getting started up again. I know it's not quite 2026. However, we're back into it. We're back in full speed. Okay, so where is this? Oh, batch. Yeah, see, that's why. Okay, good. Okay, I didn't notice this right here. So I'm pretty sure, Neva, that you wrote this right here. You wrote this line right here. Let me double check that. Where is that at here? Where is that? Batch. Here we go. Let's check. View. Did you write that? I'm pretty sure you wrote that. Batch. Where'd that at? Oh, here it is. Yep, you did. You wrote that line. Nice. Okay. So you wrote that. So then that's what I'm thinking. And then what we want to do is we're going to make it so it's this, and then we'll batch it. Where can I get the code? Oh, Mura. The code is on our Discord. So just jump over here to Discord, go into the free resources section, and it should be right here. Yeah, it's like the second message. It's the second message here on Discord. No, he's negotiating for 20 minutes. That's the terms? No, right? We have a hard terms here. Either on Discord or GitHub. Yeah, there you go. Torva, yep, you got it. So there's where the code. It's right here. And then you just click on that, and then it will take you to the spot you are looking for. Okay. So this will be one channel, which is, we're fine. Then we want to, we don't need that anymore. We just need chords because we're here in the chords. Get the link of the chords, step over it twice, create, and draw the picture. We're going to draw the picture, and then we're going to append it. And so that will take it through a batch of features that are encoded. I think that should work. Your environment running with Mac NPS. Yes, you got it. Curious what the resource usage is when training. It's actually pretty low. It's pretty low because, I mean, we're only painting. I mean, it's not a very big picture for one. It's also not a lot of data. So it's just a few pictures. So it's probably a few megabytes, maybe a gigabyte, somewhere around there. Oh, by the way, is a layer I made in one of your branches that samples from a grid down to a point. You can use this on the CNN to reduce to a flattened setup in a way that's not per pixel in the space. That would be nice because obviously that's a lot of pixels. It's a lot of pixels. So if we could reduce that, we could do that well. I was actually planning to do that right here. Sort of like doing like a division like by like, I don't know, like 100 or something. And then we would also do that as well on this, right? So we do something like that right here and here. Which, why don't we do that right now? Why don't we just do that right now? Actually, we should probably do, we should do width height. Where's that? We should do, do you say max or say min? Max. Here we go. Something like that, I suppose. Wait, no, that doesn't do what I wanted to do. I want to seal it. So how do we do that in Python? You heard it. So was it nerds? How do you say seal? Is it math? Do we have to import math? Dot seal? I think we have to import math. Import math. Try that again. Okay. Let's do that. I think we do that. You want to do, double / division. That's even better. I keep forgetting about that. All right, thank you. Now we don't even have to import math. We just do double / Hey, Neva, thank you. There we go. Neva, thank you. The jam agrees. All right, so this should give us 100 Lex on the input size. Groovebox. Yeah, you got it. Groovebox. You know it. It is Groovebox. Good eye. Storage, good eye. All right, 8 minutes. We got 8 minutes. Can you make the video in pins? What? What is pins? What do you mean? I don't know what that is. What is pens? I've never heard of that before. And if it's a typo, I don't know how to. I don't know what you're actually talking about. What is pens? Okay. Looks good. Happy with that. All right, so that's the output. 100 times less physics-informed neural networks. I've never heard of this. That sounds pretty neat. Can you make a video on pins? I would like to learn about that. I think that would be pretty neat. Steven, the last code is updated in GitHub. I want to try it on my local system offline, I guess. Sounds like good. Intel Mac. Yep. Sounds good. That should work fine. Let's see. Let's see if it runs. So yes, so currently we've got an error here. List entities must be integers or slices, not tuple. What? Isn't it? That should be fine. X coordinates. Okay, so what? Print. Let's do width, height, HEI, then X and comma Y. All right, let's print this. Let's print it a whole bunch. Let's see why it's complaining. Nope. Yes. Good. Why does it not like E? Okay, that looks good. Right? That looks perfectly fine. It's not a tuple. It's an integer. List indices must be integers or slices. Isn't it though? What are we looking at here? Is that a problem? Why is that is that not good? I think that should be good. That subtitle made my name storage. It made it strange. Storage. Storage. Yeah, storage. You got it. Storage. It says, yeah, sorry. Yeah, it won't know to recognize. Yeah, it's doing the best. It's doing the best it can. All right, we got 5 minutes, you guys. We got 5 minutes. Okay. Why is it no likey on that? So this part looks good. That's not a problem. What if we did this? Will it like that better? Okay. It doesn't even like that. That was working perfectly fine before. Interesting. Okay. All right. It was working fine before. I don't know why it's not working fine now. That's kind of weird. Okay, so I need to figure out what the deal is with that. Why though? Why? Why? It should work perfectly fine, right? Maybe. I suppose what we could do is, instead of using commas, we could do something like this. Which is, that should also work perfectly fine. Oh, it doesn't like that. Okay. It's a list, and it's likely you try to subscript suddenly. It also, list index out of range. 0 is out of range? What do you mean 0 is out of range? Oh, whoopsie. I see what I did there. I know it's wrong. Okay. Okay. All right. Yep. Okay. I got it. Sorry about that. I forgot that I changed it this. So we should maybe call this, instead of something out, we should call this image. We'll call it image. So it's something different. The list is empty. Yep. All right. Now we're good. Now we should be perfectly fine. All right. Now that won't be a problem. Okay. Append out, right? Oh, wait, right, because we changed the image. There we go. Okay, let's try that again. 4 minutes. Okay. Oh, yes, okay, yeah. Features equals permute. What is that? Permute? What is this? What is this? We did something here. Something here is happening. What is this? Do we always need to permute this? Also, it's going to be not that. So maybe this. What? I'm pretty sure you added this. So see if that works. Permute list object has no attribute permute. Is it? Oh, right. Okay. We need to make this. We have to make this a tensor. Tense. Okay, so what we're doing is we're outputting a list and not a tensor. Permute because I moved to color last. Got it. Okay. Sounds good to me. Never broke broad. I know, right? No, it's all good. It's all good. We're all good. All right, so 2 minutes. Got 2 minutes. I gotta go. Let me see here. Let me see if I can get this in 2 minutes. I don't know if I can. So this is really simple stuff here, though. So basically, we have to make the output a tensor. And maybe just make it empty. Like that. I don't know. Does that work? Can we say push, though, or append? I don't know if you can you mutate a tensor, or is it immutable? Fixes the thing I changed in the prepare. Got it. Because it's easily logical in the prepare to think of it that way. Ah, nice. Okay. Very nice. Append has no append. Right. So does it have a push? Or is it immutable? Okay. So I think it's immutable. Features. Okay, so I do got to get going. All right, so hi, what text editor is this, please? Oh, this is Vim. So Vim, here we go. See here on the screen. Vim, right here. Vim version 9. It's regular Vim. It's not Neo Vim. It's just regular Vim and Groovebox color theme. Yep, Groovebox color theme. All right, Stephen, the tensors are mutable, but to add values, you have to do stack concat. Okay, thank you. All right, that's what we do have to do. All right, so I do have to get going. So let me see. So you have to do stack like that. Output stack. Okay, let's try that. Okay, stack. Use Vim. Nice. Okay, tensor object has no attribute stack. Yeah, it does. It sure does. Okay, I gotta go. Hey, I love food. You're here. All right, Vim is the editor for the old nuts goldies. Yeah, you got it. All right, everyone, thank you for joining in. We'll be back later today, probably, is the plan. Maybe a couple hours or so. And we'll try to continue. This. I gotta get going. Thank you, everyone. Good to see ya.